Hello and welcome to my 30-minute series. Today's episode, Coding in Unity. I'm Mark Bennison. I'm a Senior Lecturer of Programming and Games Development at the University of Sunderland. So in today's episode, I would like to get you to know what game objects are, and be able to insert them into a game, and to code one of them as a player to move them around. This will get you started. We'll be using the Unity game engine. It's free to download. It's free for students as well if you've got a student email address. There are plenty of YouTube and tutorials online of all shapes and sizes that will help you download and get started in Unity just to get it open. Used to make games like Rust, Ori, and lots of other games that you might not even be aware of, like Kerbal and Fallout Shelter, all made in the Unity game engine. When you open up the Unity Hub, you'll be presented with a window that allows you to create a new project. We're going to select a 3D project, and we're going to name it Player Movement. You can name it wherever you like. Do select a location where you want to save your projects. I have a Unity projects folder, which I save all my projects into, and I have that in my documents. For me, it's on my G drive because I've got a fair few drives on my computer. Unity will present you with a screen like this. There's a few things you need to be aware of. You've got the hierarchy, which is everything that's in your scene. You start off with a sample scene. You can rename these, but I'm just going to stick to what we've got. We've got the scene window, so we can see what's in our game world. We also have a game window, which is nice to have a look at. You have an inspector, which will show the properties of the items that you have selected, and the project pane, which shows all the assets that we have. You can change the way this is viewed, which is a standard sort of files hierarchy, and everything should be within assets. We're going to set up a little file structure for that. I like to reorganize my view. I have one set up. This is my preferred layout, where I've got the scene and the game view visible straight off. I expand this hierarchy out. I've got the main camera. Zoom in on by double clicking it, and this is what the camera sees. You don't really need this version here. It's just a little version of what the camera is seeing anyway. I've got it on screen. And we have a directional light, which it doesn't matter where it is, it's more about the angle it's on, and we're not going to worry about that right now either. Then we have the project pane, which includes all the things that we're going to have in game. Right now, I'm going to create some new folders. So I'm going to create a folder for materials. And I'm going to create a folder for scripts. Straight off, I'm going to create a new material within the materials folder by clicking firstly on the folder materials. Just click on it, don't double click it, and then right click create, and then select a material. We can call this grass or green because that's all it's going to be for now. From the albedo, there's a little color selector. I'm going to pick a green color from that list. Just for now, I'm going to create another one which I'll call blue. And again, from the albedo, I'm going to select the blue. Now, we haven't got anything in our scene yet, so we're going to create something. Well, ways we can do this, we can actually go to the top here to game object and find a 3D object and insert from this list here. Or we can right click in our hierarchy, which is what I prefer to do, and go down to 3D object and pick from here. These are game objects. Game objects are items that are in game that you can often see, although they can be invisible, so I suppose that's another thing, but they can also be empty, and they have things attached to them like, you know, their position, their rotation, and various other things you can add to them. We're going to add a 3D object, plane, which is going to be our ground. We want to make sure it's centered, so we're going to change its position using the inspector, and we've got a position X, Y, and Z, so I'm going to position it 0 on the X, 0 on the Y, and 0 on the Z, just so it's fully centered. And I'm not going to change any rotations. I'm going to change the scale. The scale for planes doesn't work quite the same as other objects in that it's multiplied by a factor of 10. So if I wanted equivalent of 50 units, I only need to do 5 units and 5 units on the Z. X-axis tends to be our left and right if we're thinking of a character, and Z-axis is forwards and backwards, or the depth. If you think of a 2D game, X is typically your left to right anyway. That's why we think of it in that manner. And then Y is our height. So X is left and right, Y is our height, which is typical for a 2D game. But in a 3D game, Z is our depth, so forwards and backwards. Alright, I've got plane. We can rename it in the inspector here at the top. Where it says plane, I can rename it ground. We can also select our grass material from the project pane I'm not going to select it by clicking it, I'm actually going to click and drag it into the ground. Sometimes when you select things, they then become the thing that's highlighted, and then they appear in the inspector. So if you want to make sure the inspector keeps what it has, you can select the item and then just make sure you're not clicking on other things. If you need to drive into other things and you don't want the inspector to change, you can actually lock the inspector. And you can even view multiple inspectors by right-clicking and adding a new tab, a new inspector, and you have multiple inspectors and lock them down on certain things as you go around. Anyway, we have our ground. I'm going to right-click again in the hierarchy and select a 3D object. I'm going to go for a capsule. You can do the same with a cylinder. This is going to be our player. I'm going to move its position. I want to start with 0, 0, 0. And you will notice it's in the ground. Because it's zeroed, its axis is in relation to its center position. Because its height is 1, I'm going to move its Y position up to 1. There we go. I say its height is 1. I believe its height actually is equivalent really to 2, but it's relative to 1. Again, we can assign a color to this by clicking and dragging from blue over our capsule object. Now, at present, this game doesn't do anything. We've just got two shapes on a scene, and the view that we'll see in-game is what you see in the bottom here in the game display. Now, if we do program this player to move around, it will move around nicely, but the camera will stay still. So I'm going to do some changes for that. Firstly, I want to position the camera behind the player. Here's our camera. Now remember, I said Z is our forwards and backwards, so it's a Z that's really sets it behind. Our X should be 0 because it's central to the player. Yes, you want to offset it. If we want it slightly above the player, which we do, then we want to set to the Y value, which I think a 2 might work nicely. And then our Z should be a negative number to be set further back from the player. Now, can't see the whole player from this, we can only see its head, so we're going to actually tilt this on the X axis 15 degrees. And that might work. I think it needs to be set a little bit further away. And I'm going to go with that. So I've got a position of 0, 2, and -3. So that's central, in regard to left and right. If I move this into a positive number, it'll move to the right of the player. And if I move it to a negative number, it'll move to the left of the player. The Y position, if I set it to 0, it's in line with the ground, and incidentally, you can't see the ground from underneath the ground, so a plane, whilst it's considered a 3D object, it's effectively 2D. It only exists on one plane. Okay, select our capsule. Just looking at an object, we've got all these different items available in the inspector. We've got transform, a capsule, a mesh renderer, and a capsule collider, and then the blue material that we've added. I don't want you to worry too much about these, but what they are called components. And components are scripts that have been written for us by Unity and even have preset values in, and we can write our own scripts. So you don't need to worry too much about these at the moment. You can even hide them a little bit by collapsing them so they're less visible. We can add components using the button at the bottom of this inspector, which is add component, and there's two things we're going to add. Firstly, we're going to add a character controller. Well, if I type in char, we find a character controller and a character joint with this character controller. This will add a new component into the character, into our capsule. Let's call this capsule player. It's easy to understand what that is then. And we can set certain limits to this. The character controller, this is where engines do a lot for us. It determines, okay, this is going to be a character, and we can set some presets for this, such as how big a slope, what degree angle slope can the character move around, how big a step can it traverse, can it move around, what's, well, the skin width is not really relevant right now, min move distance. We can set the center position of the character controller, we just leave that as it is for now. We can set its radius for if we want it to be bigger than the player or smaller than the player, and its height and various other things. So we can actually set it to be equivalent to what we need it to. You actually see from the orange line around here, it has a height of 2 and a radius of 0.5. So the radius is from a top-down view. If you think this diameter would be 1, the radius is 0.5 because that's half the diameter. So just from the center to the outside edge. And then we need one more component, we need a script. Now we can actually write scripts and then add them, or we can add them and then move them where we want them to be. So I'm going to start it this way and go. We can type in script, it actually was at the bottom there, a new script. And we have to name the script straight off. I'm going to call it move script with a capital M and a capital S. Nice naming convention, a nice way to name things. It's called camel case when we use an uppercase letter at the start and uppercase letters for every new word, but we keep it as one word without spaces. So try and keep it to that as well. Create an add. And what you'll find is the move script has been added to the inspector. We can work on that in a bit. And the move script has been added to our assets library. Now, where it is not and where I want it to be is in the scripts folder. So I'm just going to click that and drag it into scripts. Now we have it in our scripts folder. This just helps keep things tidy so we know where to find things. Double click this and it should open your chosen text editor. My preference is Visual Studio. So what you get is this. You get some using statements. These are libraries. These are bits of code that's already been written for us somewhere, or lots of collections of code that's already been written for us. Where they're grayed out, they're actually not being used, so they can actually be deleted. System libraries are actually Microsoft's own .NET libraries. I'll tell you now we're not going to use them, so I'm just going to delete them. By all means, leave them in and just delete things if they remain grayed out. You must use Unity Engine because we're making something that's based on Unity Engine code. Here's our script class. It's called public class. We have an open brace and a closed brace to represent our whole class. All of our code must fall within this class. You can't type things after this closed brace. And we're not going to be using anything before the closed brace. We're not going to be using anything outside of this class right now. Comments can be written using a double / and will be appear in green. Start is called before the first frame update. Here's a start subroutine. So this subroutine runs once. When the object is created for the first time, this script will run. Now this script is added to the player. So when the player is loaded into the game, this script will run. Currently it's doing nothing. And then this update script will run every frame. So that means, say, 60 times a second potentially, this update could be running. And this is where we want to do things like move. I'm going to get started. I'm going to add in some lines within the class before the subroutines, so just to define certain variables that we're going to want to use and work with. Firstly, I want to refer to our character controller of the game object that this code's attached to. That character controller was the component that we added previously. Character controller, C# is case sensitive, so you have to use the right uppercase, lowercase letters. It should be coloured in the sort of teal bluish colour to say that this is an object in the library. So it's character controller, it knows what it's looking for, and we can call this whatever we like. I tend to call it the same thing with a lowercase letter, and that way we know what it is. I mean, I could abbreviate it to CC, as long as you know that whenever we refer to CC, we're referring to the character controller. Tell you what, let's go with that. We're going to create a float. A float is a number that can have decimal values. You may also find things called singles and doubles, which are similar. But yes, it's a decimal number. To say it's public means that we'll be able to access this from other scripts. It's not really that important for that. But we can also access it from the inspector. We can't access private fields in the inspector as easily. It is possible, just if we serialize them. That's something you might want to look at when you get into Unity a little bit. But for now, public, so that we can access it from outside the script, which you'll see it in the inspector. Float means it's a decimal number, and then we name it whatever we want to name it. So we'll give it a name. We're going to call it speed. It then equals a number, and we've gone for 6.0, and we put an F in there because it's a float. We have to say this is a float, so we put an F in there. Sometimes it lets us off without doing that. Sometimes it's a bit picky and wants us to put it in. So I'm going to need a speed for jumping, which is going to be different to our running around speed, and we'll throw in a gravity variable in case we enter that as well. And we're going to have to look at what direction are we facing. Well, the direction is a vector 3. A vector 3 allows for basically an X, Y, and Z property. Now, notice a few things. Every line is closing with a semicolon. You need those, otherwise you'll get errors. I'm setting the vector 3 to private because I don't need it accessible anywhere else. In fact, I can leave private off. Private variables will be assumed to be private if you don't directly state that they are. A vector3 0 basically presets this to be a 0x, 0y, and 0z. It's just part of the Unity engine library. Currently, we're not doing anything with these, so let's make a start by actually setting our character controller so we've got one that we can work with. This looks like a bit of complicated code. Our character controller CC, we are setting it to get the component, and this looks at the game object this code is attached to, so our capsule. And it will look for a component of type character controller. So it looks for any character controller component, and then we'll save this as our variable CC so we can reference it. Let's look back at the engine. In the engine, if I select the player now, we can have a look at our script. And we've got speed, jump speed, and gravity. Because they were public, we can see them here, and we can actually change the values from here. It won't change the value in your code when you view it, but it will change the value in the code when you actually play this game and you're debugging and testing it. So it's the inspector will override the values that you see in your code and set them to whatever you want them to set to. So the character controller is invisible here, but it's, or the code CC, sorry, is invisible here, but it's pulling in this character controller object, so we can now reference all of these values through CC in our code, and that's what we're doing with that. Currently, still not doing anything. We've just set some variables up, and now we need to actually start using them. There's this lovely property as part of the character controller called isGrounded. It returns a Boolean value, that is to say it's either true or false, and it determines whether it's on the ground or not. So I can do an if the character controller dot or cc dot isGrounded equals true, or I can do an equals false, and then run an if statement around that. The if statement condition, this is the thing here we were saying, is this equal to true, has to be within brackets. And actually, because it's a Boolean, we don't even need to say, does it equal true? We can actually leave that off and just say, is it grounded? And if we want to say, is it not grounded? There's a not equal to. Of course, we could just say, or equals false. We could have a not at the beginning, and that would actually mean not equal to is grounded. So this is checking is it false. Move it. This is checking is it true. We just want to know if it's true. Are we grounded? Open brace. When you create an open brace, it creates a closed brace. Everything needs to open and close. You can't overlap opens and closes either. So if we're grounded, first and foremost, we're going to create a new vector3. Now, a vector3 I mentioned was an x, y, z coordinate. And we're going to set this vector3 to be our move direction. Now, I appreciate there's lots of new terms in this and you might be getting a bit confused. But now it's just a case of following along with it. With coding, there's sometimes complex things that you will learn the more you get experience with this stuff. Right now we're going to pass in an x, a y, and a z value. Now our x value, we're actually going to ask for an input.getAxes. This is a Unity thing. It basically says we can get input from keyboards and mice and joysticks and all sorts. And in Unity, there's one called horizontal, which will grab our left and right movement from either A and D or the left and right arrow buttons. We also have a vertical, which will get our W and S or up and down arrow buttons. You can change these inputs through Unity, but we're just going to stick with them. If you don't word horizontal correctly with a capital H, or you misspell it in any way whatsoever, you will not get an error when you look at your debug errors, your error codes in the bottom here, or in Unity. It will not immediately tell you an error, but it won't work. So you have to be very careful that you name that right, because it won't tell you. Normally it does tell you when there's an error, because it has things like this red underline that says there's a semicolon expected, but we're still not finished, because vector3 is underlined. It says it doesn't have a constructor that takes one argument. What it's saying is we only have an x value, we need more, so we need a comma. And now we need to enter either a y value, and it will allow an xy only, or an x, y, and z. We're going to go x, y, z. We don't want to change our y value, so I'm just going to leave that as 0. Then I'm going to go comma again, and I'm going to insert a z value. Well, this is our input .getAxes vertical. Again, make sure you name this correctly with a capital V. Still got an error because I haven't closed off the new vector 3. This opens and now needs to close. So we get the direction we now want to move, and we can multiply this by our speed. This is what we're doing. Our move direction is going to equal itself multiplied by speed. If you'd rather a shorthand way of writing this, times equals will do the same thing. Up to you which one you use. We'd ask another question. What if they press the jump button? Well, this is still within the if statement to say, are we grounded? So we can't jump when we're not grounded, because that means we're falling or we're flying, and you can't jump in that situation. So if we are grounded, we're going to ask, have they pressed the jump button? You need another open close brace for this if statement. We can now also set the move direction's Y position, which we had set to 0. We're going to say this equals the jump speed. So this will set the Y value up to 8, or whatever we change that to. Now, that sets our move direction, but we haven't actually done anything with it yet. We also need to know, do we need to move this object due to gravity? To do that, we look at the Y position and we have it minus equals. So what that will do is it will, let's look at this another way, say equals move direction dot Y minus our gravity times time dot delta time. Now that's what we're doing. We can remove this and make it shorthand by just saying minus equals. So it takes the current value and subtracts the gravity times time dot delta time. Gravity is just the speed at which we're going to fall to the ground, and time dot delta time allows us to, in basic, account for the number of frames per second is what effectively we're doing. So don't worry about too much about how quite that's working. For now, I'd say just simply appreciate that we are changing the Y value to account for gravity, and we can raise this number to make it stronger gravity or lower it to make it weaker gravity. Finally, let's actually put this into action and use our move direction so actually we can move the player. We need to use the character controller and call its move function. It requires a vector 3 for motion, and we get a little tooltip here to tell us that we need a vector 3 for motion, and we're going to pass in the move direction. We actually need to do something else with this. We need to times this by time dot delta time 2 to ensure that again it accounts for the different frames per second and things. Again, don't worry too much about why for this tutorial. Appreciate that's what we do. Make sure you save the code. There should be no asterisks at the top if it's saved. If I do something, there you get an asterisk. If I save it, Control S, that's gone. Back in our project, you might want to save this and just make sure, but there should be a play button. Now I've coloured my screen red. Yours will just go a slightly different tint of grey. You can change that as well. You can make this any colour you like. But now the game is playing. And if I click in the game view and then use W and move forward, S move backwards, arrow keys can move left and right. Of course, I've got to actually have the camera follow the player. Quick fix. Stop the play, and what we can do is move the camera into the player object, so it's part of the player. So when we move the player, the camera moves with it. Clicking on the game, I can move left, right. Now it doesn't look like it's doing much on the game view, but you can see in the scene view we can see what's going on. When you get to the edge, we can see what's happening, and actually we can jump, space bar for jump. The gravity's having an effect, and I can fall off the edge. Just another quick note, while you're playing the inspector, so I just stopped that and restarted, we can change these values. Just bear in mind, while you're playing, as soon as you press stop, it'll reset the values to whatever they were before you were playing. So I can increase speed, so a bit faster. You saw it reset back to 6 when I stopped the game. I can also increase the jump speed. And I can increase or decrease gravity. I've decreased gravity, so I'll probably actually never land. I'm going to keep going up and up because the jump speed is higher than the gravity. Oh no, we'll come down eventually. Really slow. What we don't have currently is a rotation, so let's make a quick amendment to our code to get that working. Firstly, let's include a new float. Public float, rotation speed, and we're going to set this to 100F. This is how many degrees do we want to be able to move every time, every second if you like. We're now going to not use the input get axis horizontal. I'm going to cut this out so I can paste it somewhere else and just put in a 0. Insert a new line and set the move direction to equal a new transform. Transform direction with our move direction. What this will do is look at the transform of the current game object, so the player, and we'll get the transform direction of it, and we'll change the transform direction of the player to be whichever the move direction is. We'll still move the player in the direction from the vertical, so we're going to it's not going to look like it's doing much at the moment, but we're going to do a transform rotate. We're not going to rotate it on the X, we're going to rotate it on the Y, because the Y goes vertically through the object, and that's the rotation around that vertical line, if you like, that we're looking at. This is where we can paste in our input.get axis horizontal. We're going to times this as well by rotation speed. And we're going to set a Y value to 0, so comma Y. Sorry, Z's value to 0, comma Z, comma 0. This can go before or after this move. I'll show it as after just see it works. And I believe that's everything. We've still got move forward, and we've now got rotate based on the horizontal axes input. So, A and D. I'll press A. Now this is a bit too fast, isn't it? I set that to 10. Oh, maybe just set it to 2. Yeah. This is because we times it by time.delta time and made it really quick. So I think a 1 or a 2 is probably, I think 2 is quite good with that. And you can see on the top what's happening. You can see, because I've got the camera here, we can see how we're moving, rotating. And if you put little symbols on your play, but say where the front and back is, it might make it a bit easy to understand where it's rotating to as well. So a quick recap then. We went in the project pane, created a new folder for our materials and our scripts, and we added a new material called green. We actually added one called blue as well. We added a plane with the scale factor 515 and the position 000, just to get it where we wanted it. And we added a capsule as well. We named player, positioned it 010, just so it was slightly above the ground, and scale 111, we didn't change that. We added the grass material to the plane, and actually we added the blue material to the player, and we positioned the camera behind the player. And what I didn't do at the time straight away is I embedded it in the hierarchy as well into the player. I did that a bit later. That means it will follow it around. Then we created the move script, and I placed that in the script folder. We edited the script. Here's a screenshot of the code that we originally used. Bear in mind we use the move feature, which is actually less limited to another option, which would have been simple move. A simple move actually would have had gravity in play, but that means we can't manipulate the Y value so easily to do things like jumping. So we did our own, and then we use the move feature. It's frame rate dependent, and gravity had to be implemented separately for that. And we use the is grounded to work out whether it's on the ground or not. Some people say this is a bit buggy, so they sometimes make their own scripts to determine whether you're grounded. Rotation wasn't working, so we added a new float. We tried it as 100F, we ended up changing it to 2. We changed that move directions new vector 3, so we got rid of the horizontal input and changed it to 0. And then we had to move the object to face a certain direction. and we had to create a rotate using the input on the horizontal axis, so the AD or the left-right arrows. And our new script edited the lines that you have the yellow highlighting on the left-hand side. They were the additions or edits to create this script. Thank you very much. Hopefully you'll be able to get into a bit of Unity coding using C#. Takes a bit of learning, a bit of getting your head around, but stick with it, and it does get easier, I promise you. If you do have any questions, feel free to get in touch. Contact details are on screen. And I'll leave you with a show reel of what some of our first and second years have been creating in the last year.